Hello student, let's continue the class of polymer technology. In the previous class, we talked about the architecture and molecular weight of the polymer particles. So now we will come to know about the thermal properties of the polymers. So thermal property, as the name you you see thermal, it means we will be studying the heat property of the polymer. So what are the thermal property? You see the definition of a thermal property. The thermal property is shown by the textile fiber when it is subjected to heating is called thermal property. That means whenever the polymers are undergoing through a heat, so they will change their properties. So how they will change their properties, that we will study into their thermal properties. So thermal properties includes thermal conductivity, melting transition temperature, class transition temperature, heat seating, thermal expansion, heat of wetting or heat absorption, flammability. So these are the thermal properties of a polymer. So first we will come to know about the thermal conductivity. So if you talk about the thermal conductivity, this is the rate of heat transfer in degree. So this is the rate of heat transfer in degree along the body of textile fiber by the conduction. So if there is a heat transfer mode by the conduction, then the rate of heat transfer degree is called the thermal conductivity. The thermal conductivity of textile fiber depends on much greater extent on their air entrapped within that or within the fiber conductivity. So in between the two particles, the air trapped. So your conductivity depends upon that. If the conductivity is higher, means higher thermal conductivity indicates that the fiber is more conductive, means heat transfer rate is fast. In the winter season, lower conductivity fiber dress are more suitable to wear, because in the lower conductivity the heat transfer rate is very low. So in the winter season you need to make your body warm, so that heat transfer should not be very fast. So in that case you need the lower thermal conductivity cloth. So thermal conductivity mainly depends upon the following matter. First is temperature. Temperature depends upon the thermal conductivity for amorphous polymers. What are the amorphous polymers? You can see in the picture at the top. So temperature depends upon the thermal conductivity of amorphous polymer, increases gradually in glassy region and decreases slowly or remain constant in the rubbery region. So if you talk about a crystal polymer, thermal conductivity decreases steadily with increase in temperature below. At temperature above, it behaves in a similar way as amorphous polymers. So now this was the role of the temperature. Now we will come to know about the degree of crystallinity. Crystallinity. So your conductivity depends upon the degree of crystallinity. That means the thermal conductivity depends upon the degree of crystallinity. A polymer with highly crystalline and ordered structure will have higher conductivity than the amorphous polymer. So those polymer which are crystalline or their crystal arrangement is in a systematic way, so they have the higher conductivity, and amorphous polymer have the lower conductivity. Why? Because their molecular arrangement is not proper. And density of the polymer. So next, the thermal conductivity depends upon the density of the polymer. Thermal conductivity increases with increasing density of the polymer. If the high density polymer is available, so that means the thermal conductivity will be higher, and the lower density polymer will have the low thermal conductivity. orientation of chain segment. This is the another cause of the thermal conductivity. So thermal conductivity depends upon the orientation of chain segment. Thermal conductivity of polymer is highly dependent on the polymer chain segment orientation. So this is because thermal energy transport more efficient along the polymer chain, and crystalline polymer have highly oriented chain segment, and therefore higher thermal conductivity than the amorphous polymer. So amorphous polymer does not have the crystalline crystalline orientation of chain segment, and the crystalline polymer have the highly oriented chain segment. So that's why the thermal conductivity into the crystalline polymer is higher than the amorphous polymer. So next, it depends upon the structure. The cell size of a foamed polymer may also have an effect on thermal conductivity. The size of a cell of the polymer crystal that also have effect on thermal conductivity. Smaller foam size tend to lower thermal conductivity, and larger cell size will denote the higher thermal conductivity. So most foam polymer have thermal conductivity value in order of which is about to 10 times less than the some polymer. So most of the foam polymer have the thermal conductivity value in order of which is about 10 times less than the same polymer. Then the protein fiber has lower thermal conductivity than the cellulose fiber. Protein fiber that are your wool. So that's why the woolen dresses are more suitable than cellulose or synthetic dresses. Why? Because the thermal conductivity of the wool is low, and the uh, synthesis polymer, the thermal conductivity is high. Why the synthesis dresses are not suitable in the summer and winter season? So the synthesis dresses, these are not suitable for summer or winters. Why? We will come to know the reason. We know that lower thermal conductivity fiber dresses are not suitable to wear because the rate of heat transfer uh, is very low for lower thermal conductivity, and the value of thermal conductivity of synthesis fiber is higher than the natural fiber. Natural fiber, for example, cotton, silk or wool. As a result, the synthesis dresses are more conductive. Hence, the rate of heat transfer along a body is very high into the synthesis dresses. So, in the winter season, if you wear the synthesis dresses, that means your body will become cold, and in hotter season, if you wear these dresses, your body becomes hot. So you can wear it in rainy season. So in summer season, atmosphere heat is easily felt, and in the winter season, low temperature of air is also effect on the body by synthesis fiber dresses. That's why the synthesis dresses are not suitable in the summer and winter season. You can see the value of thermal conductivity of different fibers. You will see the silk have 50 thermal conductivity, 50 meg watt per Kelvin. Wool 54, cotton 71, polyester 140. Polyethylene have the highest thermal conductivity because this is a synthesis fiber. Okay, this has the highest thermal conductivity. That means the rate of heat transfer degree is very high. So this polyethylene you should not wear in winter or summer. Is it clear? Next factor or thermal property of the polymer that is glass transition temperature. So what is glass transition temperature? When the polymer cools, the temperature lowers. The mobility in the amorphous region of the polymer decreases. So that means you see, whenever you are cooling any polymer, your temperature is going down and mobility of the polymer is decreasing. So whenever the temperature of a polymer is going down, that means the mobility is decreasing. So lower the temperature, stiffer the polymer until a point of transition is reached. So whenever you keep on lowering the temperature, your stiffness of the polymer increases, and there will be a point of transition, and this transition point is called the second order transition temperature or glass transition temperature. It is denoted by Tg, and range of Tg for linear fiber is in between 200 to 300 degree centigrade. It is in minus 200 to 300 degree centigrade. So if you see, the factor influence the transition temperature is flexibility of chain bond increases the value of Tg, and second, flexibility of side group increases the value of Tg. Polarity of side group increases the value of Tg. Bulky of side group increases the value of Tg. And composition of ring structure in the molecular chain raises the value of Tg. Random copolymer has a lower value of Tg than homopolymer, and Tg increases with molecular weight up to the 2000, up to the 20,000. You can see in the graph the transition temperature at y-axis and molecular weight as at x-axis. So if the molecular weight increasing, the transition temperature increasing, and after certain value up to 20,000 molecular weight, the transition temperature start decreasing of increasing the molecular weight. So the glass transition temperature is the mechanical property of polymers radically change at the glass transition temperature, or molecular motion is underlying causes of change. So below the transition temperature there is no translational or rotational motion of the atoms, and that makes an polymer backbone. But these motions are present above transition temperature or below the transition temperature. So polymers are relatively hard, inflexible and brittle, whilst above it is if they are soft and flexible. So the term glassy, rubbery, leathery are used to describe property in the two temperature region. Next is melting temperature. So melting temperature at which the fiber melts completely, that is called first order transition temperature or melting temperature. It denotes by Tm. So what is a melting temperature? It is a temperature at which the fiber will melt completely. That is the melting temperature. At melting temperature, the fiber loses its density and convert it into the viscous liquid. At melting temperature, the fiber loses its strength and some molecules weight. That means it loses its strength and some molecules weight. So melting point depends upon composition. Polyester, for polyester the melting temperature is 264 degrees centigrade, and for PVC it is 310. Structure, larger polymer structure Tm is larger, and rigid structure Tm is larger. Bonding force, covalent force, hydrogen bond. then melting temperature is higher. So relationship between the Tg and Tm is Tg by Tm equals to 1 by 2 or 2 by 3. So 1 by 2 in case for the symmetrical polymer and 2 by 3 in case for the unsymmetrical polymers. Now next is heat seating. What is heat seating? Heat seating is a heat treatment by which shape retention, crease resistance, resilience and elasticity are imparted to the fiber. So heat seating is done before melting temperature and dyeing is done above the glass transition temperature. So this is the temperature above the glass transition temperature. If the fabric is dyed before the heat setting, we will not the desired result and fabric will be deformed. So if the fabric is dyed before the heat setting, we will not get the desired result and fabric will be deformed. So this is the heating. This kind of temperature is known as heating setting temperature, heat setting temperature. Next is thermal expansion. The thermal expansion can be measured by co coefficient of thermal expansion, and which is defined as the fraction increases in the length of a specimen to rise at, in the temperature of 1 degree centigrade. So now you can understand the thermal expansion can be measured by the coefficient of thermal expansion. It can be measured by the coefficient of thermal expansion, and in which it is defined as the fraction increases in the length whenever there is a rise of the temperature of 1 degree centigrade. So coefficient of thermal expansion can be expressed by this formula. This is length increased divided by initial length of the specimen. So d by delta L by L. So delta L is the change in the length and L is initial length. Next is heat of wetting. So when a textile fiber absorbs moisture or water, it gives off some amount of heat which is called heat of wetting. So whenever any polymer molecule absorb water or moisture, it releases the heat, and that heat is called the heat of wetting or heat of absorption. The heat of absorption resulting from changes in moisture region rather than the thermal conductivity. If 1 gram of dried textile fiber is completely wetted, then the heat is calorie per gram is involved, in which is known as the heat fiber. Now you read this definition again. If 1 gram of dried textile fiber is completely wetted, then heat is calorie per gram involved, which is known as the heat fiber. So this is the heat of wetting. So next is flammability. Flammability is defined as how easily smoothing will burn or ignite, causing the fiber or combustion. It is defined as how easily smoothing will be burned. Smoothing of the fiber will be burned or ignite, causing fiber or combustion. So it is measured by passing a mixture of oxygen and nitrogen over a bearing specimen, reducing the oxygen level until a critical level is reached. So this is the very brief information about the thermal properties of the polymer. So further we will continue in the next class. Thank you.